Hello, my name is Semyon, and today I want to present you our work, Influence of Image Preprocessing Algorithm on Segmentation Result by Method of Persistent Homology. In the process of testing an F-segmentation method on metal defect, we found the preprocessing affect the final result. So, in figure B, we show result without preprocessing. And in figure C, show with preprocessing. We decided to investigate other image preprocessing methods and their impact on segmentation. We take 4 different methods preprocessing. They are Gaussian filter, man shift, remove backspace, and commands. More I want to focus on remove backspace, figure C. Processing consists the preliminary indication of the cover range that will be replaced. Now a little about the segmentation algorithm. First, the entire image is divided into pixels, equation 1. And then relations are established between netherboard pixels, equation 2. The length of the links is calculated by equation 6. The result is shown in figure A. In figure B, we can see how on-off bounds break and a hole is formed. Each hole, according to equation 3, contains information about the iteration of its birth and death. After a certain number of iterations, connection begin to break. Connection not just pixels, but holes. This leads to the formation of a new hole. The new hole cover will be calculated by equation 5, where C is the hole cover value and D is the area. Thus, the algorithm will work until there is one single hole that occupies the entire image. At the end of the segmentation, we can view the entire history of the formation of segments, so we can ever track change in a specific segment for different iteration, as shown on the slide. The current slide shows the segmentation result for an image with and without defect. In figure D, we can see that the image without defect for the same iteration is characterized by the absence of holes. Now consider the numerical characteristic. In the table we show the number of holes of different arrays for different threshold values, iteration, of the segmentation result. For segmentation without preprocessing, the best result is achieved at a threshold value of 26. The minimum amount of noise, wholly with a small area, is achieved this iteration. The defect hole is defined well from 9 to 20%, and the horror of base material is from 50 to 100% of the total area. For segmentation with man shift preprocessing, the best value is achieved at 31 iterations. The result shows almost complete absence of noise. but we see that the defect is strongly deformed. It can adversely affect the segmentation of smaller defects. For segmentation which commands preprocessing, the best value is achieved at 31 iterations. The result shows the amount of noise more than mean shift, but the defect is not deformed. Negative properties include the need to select the number of clusters. Since we do not know in advance how many defects of different types will be presented in the image. Segmentation with preliminary cover removal achieves the best result at 49 iterations. It is noted that the amount of noise is explained by the preservation of the structure of the defect, which can be observed in the corresponding figure. Segmentation with preprocessing based on Gaussian filter shows the best result, since there are no noises at the corresponding iteration, and the shape of the defect does not have a deformation. After research on the various images of defective wood, we found that the Gaussian filtering allows to achieve better segmentation result by significantly reducing noise. Some of the result you can see on the slide. That's all. Thank you for attention.